So the task will be to determine the value of -1 raised to the power of 3 over 4. Let's begin. So we will first consider our complex number represented by z given by -1. Now -1 is a purely real number, but we can write it in a complex notation as -1 plus iota times 0. So that means the imaginary part is simply 0. The reason why we are doing this, because we want to write it in a polar form. To write a given complex number in the polar form, first we'll need to obtain the value of r. So r can be obtained by taking the square root, and within the square root we are going to take the real part, which is -1, square it, and then add it to the square of the imaginary part. This is going to give us a value of +1. Then we also need to obtain the argument of the complex number, which is theta, and theta is defined as the inverse tangent of the real imaginary part, which is 0, divided by the real part, that's -1. That means we have tangent inverse of 0. Now we have to be careful here to find out the value of theta. If we plot our complex number on the argand plane, so here we have the real part of z, which is the x-axis, and the y-axis represents the imaginary part of our complex number z. Now in this case we have the real z, which has a value of -1. So this is the value of -1, so it has no real part. Now to find out the angle theta, so we start from the positive direction of the real z-axis, so this is going to be equals to pi, meaning we can say that tangent of pi, so this value is equals to 0. We can replace the value of 0 with tangent of pi. We get tangent inverse of tangent of pi, which means tangent inverse of tangent of pi is going to give us a value pi. Now we are ready to rewrite our given complex number in the polar form. So that means z will be equals to r times cosine theta plus iota times sine theta. So we will replace the value of r with 1, and cosine theta will become cosine pi, plus iota times sine theta will become sine pi. So this is our complex number -1 represented in the polar form. What we'll do next is we are going to use the fact that cosine and sine, these are periodic functions. Since they're periodic functions, we can say that sine of theta, so this can be also represented as sine of 2 pi m plus theta, and cosine of theta can be represented as cosine of 2 pi m plus theta. So here m is an integer which can take the values 0, 1, 2, and so on. In our case, since we have cosine of pi, we can rewrite our complex number as cosine of, so instead of pi we will have 2 pi m plus pi plus iota times sine 2 pi m plus pi. So this is our complex number, which is actually -1. Now that we have our value of our complex number z, we're going to raise our z to the power of 3 over 4, which is going to give us cosine of 2 pi m plus pi plus iota times sine 2 pi m plus pi. This entire expression will be raised to the power of 3 over 4. Now here we can apply the De Moivre's theorem, which simply states that whenever we have cosine of theta plus iota times sine theta, whole raised to the power of n, so this is equals to cosine of n theta plus iota times sine of n theta. Therefore we have z raised to the power of 3 over 4. This will be equals to cosine of, so we're going to multiply 3 over 4 with to the argument of cosine as well as sine. So we have 3 over 4 multiplied to 2 pi m plus pi plus iota times sine 3 over 4 multiplied to 2 pi m plus pi. Now z we consider equals to -1, so we have -1 raised to the power of 3 over 4. So this is actually this particular expression which is given in the polar form. Now since we have to find out, actually we have to find out here the fourth root. Fourth root, because negative 1 raised to the power of 3 over 4 can be also expressed as negative 1 cube whole raised to the power of 1 over 4. So negative 1 cube is actually negative 1. So we have negative 1 raised to the power of 1 over 4. So here we have to find out the fourth root of negative 1. So this is our expression. All we have to do is, since it's a fourth root, we'll have to consider 4 values of our m. We have 0, 1, 2 and 3. And for each values of m, we're going to get the distinct roots of negative 1 raised to the power of 3 over